Welcome to another GCBASIC demonstration. This demonstration is part one of a series of videos for the PIC18xxQ20 chip family. So this video, like it, subscribe. Need the numbers to essentially get the volumes up, okay? So please like it, subscribe. Let's move on. What is the Q20? High performance PIC18, digital analog peripherals, ADCs, I2C, SPI, IC3. We'll look at that much later on. PMW, two types, uses CLC, and it comes in 14 pin or 20 pin devices at the time of this video, 2024. We're going to do 19 videos. You should go and look at the primer on how to install the IDE and get operational, but that's out there. So what is the GCBASIC compiler? It's a tool chain, it's open source, downloadable, and it now supports the Q20 chip family along with about 1,200 other 8-bit PICs and AVRs and LGTs. So what we're going to do is do a basic setup. We're going to flash the LED because we have installed the software, we've installed the programmer, and we have it operational. Let me just show you that. I'm going to use PIC-Kit Plus. I have a PIC-Kit 2 installed, and here is the software. Let me zoom in on that for you. I'll just put that in the screen so you can see it. And if I actually, it says here that PIC18xxQ20 attached. Let's look at we've actually got it attached up. What it is, it's this here. There's a PIC-Kit 2 attached here through the programming lead. It's programmed into this 18Q20 here. 18Q20 has some output ports along this top edge for me, and I've linked those into 4 LEDs that are down here. And what we're going to do over the first series of videos is operate these 4 LEDs. I've got switches on here, I've got ADCs, I've got all manner of things on this test board. This is a board that I had manufactured a few years ago, very useful. I can select the voltage of the board, but we're not going into electronics here necessarily, but essentially what I've got is a PIC being programmed by a PIC-Kit 2, and I've got some resistors attached via these flying leads down to these LEDs. And on the other side, there were some LEDs, so just resistors, sorry. And we're going to make that work. So let's go look back at what we're doing in terms of the slides. So I spoke about this. I've got a prototype board. I'll run it at 5 volts. I don't really care if it's 3 volts. We'll have a look at that later on. I've got a programmer attached, LEDs and resistors, and port C7, 6, 5 and 4 are the ones we're actually going to be using down here initially. And we might move these about, but I'll keep this up to date and you can see this change. Now these slides are here and published so that you can walk through these slowly. So I've installed my hardware, I've made it work. Let's do some programming, shall we? Okay. So I've got the IDE operational, it's running there, it's empty, there's nothing in there at all. So I'm going to open up the first demonstration file. I'm going to open the folder, and that folder I've had open before, and it's this folder here. It's the vendor boards, Great Cal Basic Demos, Q20 chip range demonstrations, and it opens up the folder, but I don't see it on the screen because I need to press Control B. Control B will open it all up. A couple of things that you should see. You can filter in the folder. You can type in a filter. You can go GCB and turn a filter on just to see the GCB files. You can see here they're in different color codes, and that's just the way the IDE works, and you can figure that out on your own. So there are other files in here that I've been using, but what I'm going to do is I'm just going to show you that you can clean out these folders by pressing Function key F4, type in the word clean, and it will clean out the folder. It will get rid of the files that are in that folder. So I want Hello World GCB, Function key F4, press clean, and it will clean up the folder. There we go. Those other files have gone. So let's have a look at my program we're going to be using. Here it is. Anything in green is comments. And you can zoom in and out by pressing the Control+ key. and the control minus key, and that will zoom the IDE in and out. It does it for you, and it's not just that something me capturing video, it does it live on the screen. Control B to shut the folder down for the time being, so we can just focus. Anything in green is commentary, so inside of here I've got some words for you that you can read in your own. Minimize that. That's my chief technologist. A few lines of code. 16Q20, that's the chip I've got installed. Option explicit, just put it in your programs. It means you need to have your variables defined. And you've seen this before. It's the hardware I've got operational. I've got an LED on 7, port C.7. So down here in my program, I'm going to set port C.7 as an out, set port C.7 1, or turn it on. You could use the word on as well. And then we're going to say end, and that will put the chip to sleep. If I press function key F4, hex, and type in the word hex, it will make a hexadecimal file. The terminal window opens up and it gives us some information. And it says it's compiled 5 lines of code, which is what we counted. Go back and count them. There's 5 lines of code. There's one subroutine been created. It's used 32 words and no RAM. And it set the frequency to 64 megahertz. And it did all that in no time at all. Now, I've already got it set, my programmer set up. How have I set my programmer up? Function key F4 into the pref, type pref, edit preferences. And in here, you can see I've got selected PIC18 Plus as my top. Let me just move that along for you. As my top entry. So it's always going to select that, just for clarity, okay? I could actually have it power on and off. I'll put that one to the top because I've got power on the board. But PIC18 Plus, it actually turns the power off if the power is applied. That's okay. So now I've got a program that I've made a hex. I've checked my programmer for the first time. I press function key F5, or I can select it via function key F4, and it will download it after it's compiled it. If we go to desk cam, we have an LED that's on. It flashed it for the first few times. That's because the power settling down from the PIC18 programmer was doing some resets to ensure it exits successfully. Now we can see there's an LED on here, which is power to the board. This is power to from our little program. And we can zoom in on that because we might want to later on. So let's just zoom in and see what we've got there. There we go. Really simple program. What did we do? We'll recap. Go back to the editor. We selected the chip, set option explicit, line 2. Line 3, we set the port to an out. Line 4, set port C7 to 1. Let's set it to high or on. End. 5 lines of code programmed. Very simple. Let's save that, close it down, and select our second way of turning LEDs on. Blink number 20. In here, it says the same thing at the top. Got the hardware chip. We won't be looking at that anymore because I'm going to assume that's there. Port C out. It says, oh, there's a do loop. Do loop. You can see there's a line that says it's a loop. Do loop. It's going to do this forever. Set port C to 255, which essentially sets all the bits on. 255 hexadecimal is FF. 255 in binary is 1111 1111. Set them all on. Wait for 500 milliseconds. Set port C to 0 and turn it off. If I press function key F6 to compile the program, I'll shut the folder down. We'll look at memory usage. So what have we got here? We've got 4 bytes of RAM being used, and we've got 63 words being used. GCSBASIC does a lot of the initial setup. It does automatic configuration of the config, but we will be able to change that config as we progress through these demonstrations. In the background, it's generated an assembly file. We'll look at that. I'm going to shut that window down. Function key F4, type in the word ASM, open ASM. And this is the assembly file it's created. We'll look at this later on in the demonstrations, but the compiler has added all the configuration. It's created the 4 variables required. It's told you where it's put them in memory. It's then written the program out for you to do exactly what we wanted it to do. Now, we can actually put our basic comments into the program, and we'll do that as we progress. We might do that on the next demonstration. So let's see this working. Function key F5 to program it. We'll look out desk cam. Desk cam has still got one LED lit. It's just now programming it. 4 LEDs. There we go. It works. Very simple. Let's look at the third way of lighting these LEDs. Blink another way. This program sets up the hardware, maintains that you have to have variables, 4 LEDs in our little map here, and it says the following. Hash define LED7. I wonder what that means. LED7 is a constant. It's always a constant, and it's constantly going to be port C.7 forever. Whenever you see LED D7, it's always going to be port C.7. And this means that you change it in one place, and you don't have to change the rest of the program where you've used that constant will be automatically updated. We'll change this in a moment. It sets the direction to out. It then does that nice do loop for us. And it says here, wait for 100 milliseconds. It's a second effectively. GCBASIC has automatic delays, the wait command. They are calculated for you automatically as when you set the frequency of the chip. And the frequency of this chip is not specified. So it's always the fastest. And we'll have a look at that. And it says here, LED7, D7 is not LED7. So it's basically not value. Turn it off and on every 1 second. It's compiling it, blinking another way. It's programming it. We'll go back to desk cam. 1 LED D7 is flashing. So if I change that constant to 4, program it by pressing F5, which creates the hex, and then programmed it, and go out to desk cam, we'll see it do it here. And there it is, 4. Now, if I'm correct, I think we can, right, tomorrow I'll load up another camera so we can see this doing without me having to flash in and out here. But I can change the constant. And when I change the constant and reprogram it, it then actually in the physical hardware changes it from 4, 5 to 6. And this is port 7, remember. So we're doing the basics here. Why are we doing the basics? Because it's good to start with the basics and walk through on this highly complex chip, because it will get very complicated. And that's all I wanted to do on this first step. Remember, you've installed the hardware and you've got 3 LEDs working. What we're going to do tomorrow is make 4 LEDs. Those 4 LEDs flash in sequence. And so we've got 19 to go. Tomorrow, make 4 LEDs flash in sequence, which means we've got to use some RAM. Enjoy.